Hey, AP Chemsters, this is Mrs. Vanderlei bringing you Blankwalle 5.4. So we left off in 5.3 and we talked about the different gas laws. We talked about Boyle's law, which is pressure related to volume in an indirect way. We found Charles's law, which related to volume and temperature. That was direct. Gay-Lussac, pressure, temperature, that was direct. Even Avogadro, which is volume and number of moles, that was direct, okay? So the four quantities described with your pressure, volume, temperature, and moles. So if we combined all three laws, then we'll get something like this right here. Now, wait a minute. I don't typically see it that way. I'll look at it this way. So PV, and this is the symbol that represents is directly related to NT. So what would happen if I were to draw a graph? All right, here's my PV is my one axis, my NT is my other axis, and because it is directly related, all right, we divide, it's a straight line, okay? We would straight line. So if I were to divide, I get a constant, okay? So if I take PV divided by NT, I get a constant. What if I were to take that slope? Okay, well, does that ring a bell? If I took a slope of this, that's going to be 0.0821, all right? And you might recognize that as being the value for R. So instead of having the directly related sign, I'm going to put my constant there, so PV equals nRT, so PIV NER. I know this is a little bit off, but look at the units of R, and this is super duper important, okay? The units must be liters atmospheres over moles Kelvin. Why is this super duper important? Because we did Boyle's law earlier. I think we did a problem using torr. I think we've done a problem using milliliters, okay? And it didn't make any difference as long as the units canceled out. Now, one of them, the units were both in torr or millimeters of mercury or whatever, and atmospheres, and I converted one, which is okay. I didn't have to pick atmospheres. I could have converted atmospheres into its other unit and still get the exact same answer. So that didn't make any difference. But when you are dealing with R, okay, when you are dealing with R, your units must be in liters, your units must be in atmospheres. Typically moles is moles. If you're given grams, periodic table, you can get moles that way. And of course, what I already tell you, this entire unit, you must be in Kelvin anyway, okay? So look at the first problem. A sample of hydrogen gas is a volume of 8.56 liters. Why did I put a little heart over it? Yours doesn't have a heart. I put that heart there because look at the unit. It's already in liters. I don't have to deal with it. A temperature of 0 degrees Celsius. Well, all right, you have to deal with that at 273. And a pressure of what? 1.5 atmospheres. Calculate the moles of hydrogen present in the sample. Do I need to convert my volume or my pressure? The answer is no. What's the only thing I need to convert is my temperature. So let's go ahead and do this. All right, so I have PV equals nRT, PIV NER. I think you all probably remember PIV NER. And I'm just going to plug all these numbers in. So here's my PV, all right, equals nRT. Notice I added to Kelvin. So when I solve for n, what will I do? Take 1.5 times 8.56, divide it by 0.0821, divide it by 273, and what do you get? I got this. Now I'm going to show you something with my units, okay? My atmospheres, come here. There we go, cancels my atmospheres. My liters cancels my liters. Let me scroll down a little bit. There we go. My Kelvin cancels out my Kelvin. What unit am I left with? Mole. What would have happened if this were in torr? Could you have canceled them out? No, you can't. All right, so you're going to be wrong, okay? If you can cancel all your units except for the one you're looking for, then you did it right. Okay, that's why writing down your units are so important. And when I told you at the beginning of this chapter that it's your self-check, it's because of if the units cancel out, that's your self-check, okay? So let's take a look at problem number 9, okay? So calculate the volume of 525 grams of oxygen at 25.7 torr and 25 degrees Celsius. You have some problems. Notice I put little X's over there. What does that mean? The units are the PIV NER units. I got grams, I need moles. I got torrs, I need atmospheres. All right. So why don't you go ahead and work on this problem, and then let's see how you do. So pause this. Convert what you need to convert, solve for volume, and come back when you're done. Bye. Okay, so this is what I did. Over here, I converted my atmosphere, my torrs to my atmospheres. I got 0.0338 atmospheres. I converted my grams into moles, and I got 16.4 moles. So I plugged these values in, 0.0388 atmospheres, volume, my 16.4 moles, here's my R, here's my T. So notice what happens. My atmospheres cancels out, my moles cancels out, my Kelvin cancels out. So how did I solve for my volume? I'm circling that. I took 16.4 times 0.0821 times 298 divided by 0.0388, and I got this many liters. Why 3 sig figs? I got 3 sig figs here. I have 3 sig figs here. I have 3 sig figs with my temperature, so I think I better have 3 sig figs. Hey, by the way, how many sig figs does my R have? Is it 3? No, it's infinite. Never use that for your sig fig count, okay? So why don't we go ahead and look at the next one, okay? It says a sample containing 0.35 mole, that's good, of argon gas is a temperature of 13 degrees Celsius. Of course, you'll need to fix that. And a pressure, I see a next there, 568 torr is heated to 56 degrees Celsius and a pressure. Calculate the change of the volume occurs. Well, I need a change in volume. That means I need an original volume. Well, how am I going to figure out the original volume? They didn't give it to me. Oh, they gave me moles, temperature, and pressure, though. So what does that mean? Can I figure out the initial volume? Yes, you can. And then you got to plug it in and then solve for the new volume. All right, so let's see how I did this. So I'm going to use Pivnert. I'm going to solve for the first volume. Why don't you go ahead and do the same thing? So why don't you go ahead and pause this and at least solve for the original volume. All right, so I used Pivnert because I have a pressure. How did I get that? I divided 568 by 760, and I got 0.747 atmospheres. Here's my initial volume. Here's my initial moles, RT, and I found volume is 11. Okay, so now what? Everything is changing. I have a new pressure. I have a new volume because they're telling me I do. I have a new temperature. So what equation tells you if you have a change? Well, that's your combined gas law. So go ahead now and use the combined gas law and figure out what the new volume is. So go ahead and pause this and see how you do. All right, so is it okay that I left everything in torr? Yes, it is. Unless you're using Pivnert, you can be in whatever unit you want to be, except for the Kelvin, of course, right? So I just kept everything in torr. Why making a chance of making another mistake or something, or any mistake? So I have my 568 and my 11. Actually, it's 11 liters, isn't it? Change this to a liter, please. And then here's my Kelvin, here's my new torr, new volume, new Kelvin. And when I multiply, divide, then I'm going to do what? I'm going to multiply, oops, don't do that, please. I'm going to multiply by 329, and I'm going to divide by 897. I get 8.3 liters. So once again, get rid of the milli. It's just plain old liters there. And so that is your answer. Hopefully that makes sense. Why did I have to use Pivnert first? Because I didn't have an initial volume. I had to use Pivnert to find out what that initial conditioned volume was. Once I did that, then I used the combined gas law to figure out what the new volume is. So we're at the end of 5.4. So I'll say it once again, don't wait to be great. We'll see you next time at 5.5. Bye.